Okay, this was number 33 from the Are You Ready for Calculus? And I just kind of drew a sketch here because it's pretty easy. This was the problem, as you see here, number 33. A function has a graph to the right, sketch the inverse function. All you're basically doing is, and they gave you the line y equals x. The inverse function is just symmetrical to that line from the original function. So all you do is just draw these little line segments that are perpendicular to this line y equals x, and then put a point on exactly the opposite side of this line. So I took this point over here, this point's on the line, so it's the same. Here's my original graph, so I drew a line across. I drew that point. And then here's another one, so I draw a line, another point across there. Here's a point I picked, and I went right across it, just draw a perpendicular line, and this is another point. And then you would just sketch it. So if you looked at the answer, it kind of goes like this. So just sketch that. So that was pretty easy. So that's the easiest way to do that. Just make a straight perpendicular line, so line y equals x, and go right on the opposite side. Draw yourself a few guide points, and then lock that in. So that was number 33. And then number 34, let's take a look at this. Express x in terms of the other variables in the picture. Now what we have here are two similar triangles. We've got a big triangle and a small triangle. And since they both are right triangles and they both have this angle in common, then by angle, they're similar. That means the ratio of the corresponding sides is proportional. All right, so I'll just zoom out a little bit here. So this is real easy. So if I take a look at this, I can say R is in the big triangle, H is in the small triangle. Okay, and then this side is the side of the big triangle, which is x plus t all over t. So I can say R over H equals this side, which is x plus t over t. So this is what we have. Okay, so R over H equals x plus t over t. Then I just solve for x. So I cross multiply. So RT equals H times x plus t. Then I can multiply out, distribute hx plus ht equals RT. Then I can subtract ht from both sides. And then I can divide both sides by h. And then I could factor out the t. And this is what you have. So that's all you basically had to do for 34A. Now this was a sketch on 34B, and it's the same idea. We're going to use similar triangles. But if we notice, we don't have exactly enough data to do this. We have this side is the hypotenuse of the large triangle, and R is the hypotenuse of the small triangle, so we've got x and R. But for the large triangle, we have this side t. Now we don't have this, so can't work with h. We have this side t, but we don't have this side of the small triangle. We've got h and r. So we have to find this side, so we can use the Pythagorean theorem, and we can say that h squared plus y squared equals r squared. H squared plus y squared equals r squared. Then subtract h squared from both sides, and then take the square root of both sides. So y, this side here, equals the square root of r squared minus h squared. So then we know that big triangle x to r, again these triangles are similar by angle, that's a common angle to both triangles, that's in the small triangle and the large triangle. So we know this large side, so we can say x is to r as t is to y. But we don't have y isn't one of our given variables, so we have to use just the variables in the picture. All right, so x is to r as t is to y, but we found out that y was the square root of r squared plus h squared over here, you see. And then once we have that, all we have to do is multiply both sides by r, and then you have it. RT over the square root of r squared minus h squared, that equals x. So that's your solution. So that wasn't too bad. We do see problems like that, okay, where we have to kind of solve for things like this and then write it in this fashion. Okay? Hope that makes sense.